Karonga mwanako imona. Wewe bitiri we. We kuranga na wewe. Awe mapepe kuna kukuneda tukuzikwa pisura pano.
We proceed now into section 6.2. This is a rather lengthy part of the book, and we are not going to go over everything in it, at least in the video, but I do leave it to you to look at the book, read it very carefully. There are a couple of theorems there that are rather lengthy. Theorem 6.2.2 gives you a whole list of set identities, and again, as I've indicated, we're not going to go through all of these, but we'll do one just to indicate how these proofs might proceed. You will note that when you look at these properties, some of them are very, very similar to the ones that we saw before when we were looking at the propositional logic and the first order predicate logic. So what I want to do here is I want to consider the following, and we have to prove something. And what we're trying to prove here is the following, that A union B intersection C is equal to A union B intersection A union C. Now, let's remember a couple of things here. We're trying to show that two things are equal. We're making a statement about sets. So the proof is going to be composed of two different proofs. Okay, so we have part A. We need to show that this, the left side, is a subset of the right side. So we need to show that if X is an element of A union B intersection C, then X is contained in A union B intersection A union C. And remember, what this is showing, once we show this step over here, then what we have shown is we have shown that A union B intersection C is a subset of A union B intersection A union C. Then part B of the proof is to work in the other direction. If X is contained in A union B intersection A union C, then X is an element of A union B intersection C. And remember that if we've shown that, then what we have shown is that A union B intersection A union C, we have shown that that is a subset of A union B intersection C. So we have a lot to do here. And we're going to start off with part A. Okay, so part A says, suppose X is an element of A union B intersection C. Then, that should be an N, excuse me. Then, X is an element of A, or X is an element of B intersection C. Okay, now we're going to take this part and we have to break this up into two parts. So this proof is getting a little bit complicated. Remember, so far we're only working on part A. So I'm going to come over here and I'm going to say part A. And I say, suppose X is an element of A. Now, if X is an element of A, then X is also an element of A union B. And this is one of the identities that's given in this section, but I ask you to think about it. It's pretty obvious. If X is an A, then X is certainly an A union B. No problem there. But we can even say more. If X is an A, then X is not only an A union B, but then X is contained in A union C. So notice what we've said here now. If X is an A, X is in A union B, it's also in A union C. Notice this key word here, and, okay, so I can say we may conclude that X is in A union B, intersection A union C. And we're done. We're done with part AA. Now remember what that was. First of all, we had two major pieces to prove, and underneath each one of these major pieces, we're going to see we have minor pieces. So we've just proved part AA, if you will. Now I'm going to say, suppose the following. Well, remember we said at the top here, part A, if X is in A union B intersection C, then X is in A or X is in B intersection C. Well, we've taken care of the X's contained in A. So part B, I'm going to say, suppose X is contained in B intersection C. Now, if that's true, then X is contained in B and X is contained in C. Okay, now we're going to do basically the same trick that we did before, okay? If X is contained in B, what may we conclude? Well, if X is contained in B, then X is contained in A union B. I hope that's clear to everybody. And similarly, if X is contained in C, then X is contained in A union C. So likewise, X is contained in A union C. And now I have X is contained in A union B and X is contained in A union C. Therefore, thus, X is contained in A union B, intersection A union C. And we're done with part AB. Okay? So what we have shown here so far, we've done AA and AB. We've proven this part right here. Now what we need to do is we need to prove this part right here. Okay, so we're up to part B of the proof. And for part B of the proof, we need to show if X is in A union B, intersection A union C, the word if here. If X is in that, then X is contained in A union B intersection C. Okay? So let's see what we can do with this. And again, this is going to be broken up into two parts. So basically, the two parts are going to be, we're going to have part BA. And in part BA, we will assume X is contained in A. Okay, now if we have that X is contained in A union B intersection A union C, then X is contained in A union B and X is contained in A union C. Okay, the and corresponds to the intersection over here. Okay, but if we're assuming that X is in A, okay, we really didn't even have to do this, then clearly X is contained in A union B intersection C. Okay? If X is in A, then clearly X is in this thing as well. Okay, that was the easy one. Suppose I do part, I'm going to call it BB. And here we're going to assume that X isn't in A. Okay? Okay, now if X isn't in A and but X is contained in A union B intersection A union C. Let's think about what that means. Then X is contained in A union B and X is contained in A union C. But if X is not in A and X is in A union B, this tells me that X is in B. And if X is not in A but X is in A union C, this tells me that X is in C. Okay, so I have X is in B and X is in C. These two things together would tell me that X is contained in B intersection C. And if X is contained in B intersection C, then, well, let me write this as a complete sentence. If X is contained in B intersection C, then X is contained in A union B intersection C. And that completes the whole proof. Okay, so to do this particular proof, we actually had 4 different cases that we had to consider here. It took us 2 cases to go one way and 2 cases to go the other. You'll find that a lot of the proofs in this section follow a very similar pattern.